Hi everyone, today we're going to be doing lesson 4 in unit F. We're going to be representing inequalities. Today is a day when what we know about inequalities intersects with what we know about y equals mx plus b. Let's get started. This first question asks us when we're going to use a dotted line versus a solid line when representing an inequality on a graph. This is similar to when we worked with inequalities on a number line and we used an open circle to represent greater than or less than, and we used a closed circle to represent greater than or equal to or less than or equal to. In this case, we'll use a dotted line when we're representing greater than or less than, and we'll use a solid line when we're representing greater than or equal to or less than or equal to. Question number 2 asks us to identify 2 points that would satisfy the inequality y is greater than 2 and to use a graph to represent the inequality. Let's start with that. If we draw the line y equals 2, we know that it will be a horizontal line and that it will have an intercept of 2. Since the inequality is saying y is greater than 2, we know that it's going to be everything above this line that would be included in the inequality. We'll make the line dotted because the inequality says greater than and not greater than or equal to, and we'll be able to shade everything above the line. So if we want to name 2 points within this inequality, we're going to need to pick points that are in the shaded region. So something like 2, 5. As we plot this, would be clearly within the shaded area. We could also do something like -3, 4. It will also be within the inequality. As long as we pick a point that has a y value greater than 2, it will be in the shaded region and would therefore satisfy the inequality. Now we're being asked to name 2 points that would satisfy the inequality that's already represented below. So we'll first look at what the inequality is showing us. The inequality is showing us a vertical line that passes through 3 on the x-axis. We know that the line itself would be x is equal to 3. As an inequality, though, we need to pay attention to the fact that that line is a solid line. So we're going to use a equal to as part of our inequality. We can see that it's everything that is smaller than x is equal to 3. Or x is less than or equal to 3. So to name some points that would satisfy this inequality, all we need to do is name points that have x values that are less than or equal to 3. So 3, 4 would satisfy the inequality because it would be on the line but within the shaded region. We also could do something like -4, 2. This also would be within the shaded region and would thus satisfy the inequality. This inequality that's represented here also is represented with a solid line. So we know that our inequality is going to have an equal to portion of it. Since all the shaded region is below the line, we know that it's going to be less than or equal to. What we need to do then is determine the equation of that line. We can see that it has a y-intercept of 4, so its b value will be 4, and we'll have to find its slope. So we can see that if we make a right triangle, our rise is going to be -2 and our run will be 3. So our equation would be y equals -2/3x plus 4. Since we're representing an inequality, we'll change that equal sign to a less than or equal to. So our inequality will be y is less than or equal to -2/3x plus 4. Question number 5 asks us to determine if the point 4, -2 satisfies the inequality y is greater than or equal to -2x plus 5. Let's begin by plotting the line y equals -2x plus 5. We'll start at the y-intercept of 5 and we'll count our slope down 2 and over 1. We can repeat this count over and over until we run out of space on our grid. Then we have to figure out what portion of our graph we're going to shade. Since our inequality says y is greater than or equal to that line, then we know that our shading is going to be above the line or anything greater than those values for y. We also know that the line needs to be solid because our inequality symbol is greater than or equal to. Then we can look at the point. The point is 4, 2, or from the origin over 4 in the positive direction and down 2. This is clearly within the shaded region, so it means that the point does in fact satisfy the inequality that was given. We also could have verified if this point satisfies the inequality by substituting the x and y values into the inequality to see if it holds true. We would sub the -2 of the point into y, and we would sub the 4, or the x value, into the x in their equation. This would give us -2 is greater than or equal to -2 times 4 plus 5. Let's work out what's happening on the right side of this inequality. We would have -8 plus 5, or -3. The inequality would then read -2 is greater than or equal to -3, which we know to be true. So the point satisfies the inequality using algebra as well as it did when we made the graph. Good luck with your work representing inequalities.